Hello everyone, my name is Tarun and I'm from CSE department and my roll number is 22211A0539 and in this video I'm going to explain about decision versus optimization problems. So what is decision problems? These decision problems are the problems which has a solution in only two, like we have the solution yes or else no. If there is a solution to the given problem, which is a decision problem, obviously, then we have to return yes if there is a solution. And if there is no solution to that decision problem, then we have to return no. So there will be given a decision problem and we have to find a solution according to the given criteria. And if there is a if there exists a solution according to the given criteria, then we have to return yes. And if there is no solution according to the given criteria, then we have to return no. So this is the main goal in decision problems. So there will be only two solutions, either yes or no. And it is completely different from optimization problems, which will be explained afterwards. And there are many examples of decision problems. Three of them are graph coloring problem, subset sum problem, satisfiability problem, or SAT problem. These are some of the examples of decision problems. So let me explain each of these. And first one is graph coloring problem. The graph coloring problem is one of the example of decision problems. And in this graph coloring problem, we will be given a graph and k colors, and we have to color the graph in such a way that the no two adjacent vertices have the same color. In graph, we will contain in graph it contains vertices and edges, and we have to color the vertices in such a way that no two adjacent vertices have the same color. If we color that graph like that, then we can say that the graph can be colored and we have to return yes. And if there is if there is a k colors and there is a given graph, and if we cannot color the graph in such a way that no two adjacent vertices have the same color, then we have to return no. If we color the graph correctly, then we can return yes, and if we cannot, then we have to return no. So this is the main goal of graph coloring problem. The next one is subset sum problem. This is also an example of decision problems. In subset sum problem, we will be given a set of integers and a target sum, and we have to find whether there will be a subset of the integers that adds up to the target sum. We will be given a target sum and we have to check whether there will be a subset in this set of integers. If if this subset is there in those set of integers, then we have to return yes. And if there is no subset whose sum is equal to the target sum, then we have to return no. So this is the main goal of subset sum problem. And the other example of a decision problem is satisfiability problem, or else we can call it a SAT problem. In this satisfiability problem or SAT problem, we will be given a Boolean formula and we have to check whether there will be an assignment of truth values to the variables that makes the formula true. Like we have to check whether there will be assignment of truth values exist to the variables so that the given Boolean formula is true for the truth values. If the Boolean formula is true, then we have to return yes. The Boolean formula is like false, then we have to return no. So this is the main objective of this satisfiability problem. Next, optimization problems. So this optimization problems is completely different from decision problems. Unlike decision problems, optimization problems has to return the optimal solution. There will be many solutions of these optimization problems. There can exist more than one solution for these optimization problems, but we have to return the most optimal solution among the set of feasible solutions. The main goal in this optimization problems is to maximize or minimize an objective function. So there can be many examples of these optimization problems. Three of them are traveling salesperson problem, which is a very popular one, and an knapsack problem and linear programming. So these are the three examples of optimization problems. So traveling salesperson problem, TSP, we can call it. Like in this traveling salesperson problem, there will be given a list of cities and the distances between them, and we have to find the shortest possible route that can salesman can visit each city exactly once and return to the original city. So we have to find the shortest possible route so that the salesman can visit each city exactly once and returns to the original city. In this traveling salesperson problem, there can be exist more than one solution. There can be a set of feasible solutions, but we have to find the most optimal solution and we have to return that most optimal solution. That is the main goal of traveling salesperson problem. The other example of the other example is knapsack problem, which is also an optimization problem. In this knapsack problem, there will be given a set of items and their weights and a value. In this set of items, each item will be associated with a value and associated with a weight. And we have to determine or we have to find the number of each item, number of items to include in a collection. There will be a collection and we have to find the number of items that can be included in this collection so that the total weight is within the capacity limit, is less than or equal to this capacity limit, and the total value is maximized. So there cannot be other total value that is maximum than this total value. Then total value can be called as maximized total value, and we have to find that total value. So in this knapsack problem, we have to return the number of items that can be included in a collection so that the total weight is within the capacity limit. The total weight is nothing but the sum of the weights of the items present in that set, and the total value is nothing but the sum of the values of the items that are present in this set. And we have to return the number of items that can be included in collections. So in the collection, so that is the main goal of this knapsack problem. And the other example of optimization problem is linear programming. The linear programming objective is to maximize or minimize a linear objective function. There will be a linear objective function and we have to maximize or minimize this linear objective function, and that has to be subject to a set of linear equality and inequality constraints. So this is the main object of linear programming, which is one of the examples of optimization problems. There are many applications of this linear programming. Some of them are economics, engineering, military, transportation, and logistics. In these fields, the linear programming can be applicable. So that is all about decision versus optimization problems. Thank you.